All right, this is the rate puzzle. Let's go ahead and make a diagram for our puzzles. It makes it a lot easier. What do we know? Leo's flying to Hawaii and back. So let me draw a picture of that. I'm going to call that position home, and let's call this position Hawaii. Okay, so here's my diagram. She goes from home to Hawaii, and then from Hawaii back home. Excellent diagram. All right, it took her 7 hours longer to go there. So to go from home to Hawaii. So I'm just going to make a note here. It's plus 7 hours from what? I don't know the total amount of time. I just know it's plus 7 hours compared to that flight down there. I guess there was really bad weather or something. Okay, the average speed of the trip there, that means from home to Hawaii, was 180 kilometers per hour. I'm going to write down that speed. I'm going to say 180 kilometers per hour. So I have that done. The average speed on the way back, so from Hawaii back home, was 432 kilometers per hour. 432 kilometers per hour. How many hours did the trip there take? So we're looking for time up here. I'll call this time for the trip there from home to Hawaii. All right, so again, everything is always based off of an equation for these rate puzzles, which is distance is equal to rate times time. So let's go ahead and know this one extra piece of information, which is the distance to go from home to Hawaii. I'm assuming your home hasn't grown legs and moved. I mean, some people have mobile homes. Let's assume it's not a mobile home. It's not like a camper or something, and Hawaii usually doesn't move, at least very fast. So this distance is going to be constant between home and Hawaii, which means I'm essentially making an equation that says this. It's very silly to write this, but I'm going to say that the distance is equal to the distance, because these two distances are the same. That's not very helpful because I don't know what the distance even is. I only know a speed, and the fact that one took 7 hours more. But what I can do is I can say, okay, well, that distance is really rate times time. So let's swap these out and say this is really rate times time is equal to rate times time. Let's go ahead and just make a note here. I'm going to say to Hawaii, and this is from Hawaii. Maybe that's not the best way to write that. Maybe, whoa, that eraser was a little bit too big. I'll say, I'm going to be lame here. I'm just going to call that trip 1 and trip 2. So this one is for trip 1, and this one is for trip 2. Okay, so do we know any of these? Can we plug these in? Is there a rate for trip 1? Well, trip 1 is up here, and it says that the rate or the speed is 180. So let's plug that in. We can say U are 180. Do we know the time? I wish so, because then that would be the answer, right? So I'm going to go ahead and make a note to myself. I'm going to underline the t. That's the one that we really want. If we can solve for that t, that's the time that it takes to go there. That's what we're trying to find. How many hours did the trip there take? What about the rate for trip 2? The rate for trip 2 is telling us on this trip it's 432. So let's cross you out and say this is really 432. Okay, well, we obviously need to find the time, so we have one variable with one equation, but we don't have the time. It didn't tell us how long this trip took, so we're kind of out of luck. So let me rewrite the equation that we have. I have said that 180, I need different variables because I don't want to use the same variable types. This time and this time are not necessarily the same time. They're different variables. So let me make up my own variables. Let's go ahead and call this time, I'm going to call it X. And then this time down here, I'll call this this time down here on the return trip. This time is going to be time Y. So be very careful. Sometimes your variables will be a rate. Sometimes your variable will be a distance. In this case, our variable is time. It's going to be one of these three, right? So in this case, I think I've clearly labeled it. Those are both times. So I'm going to swap out. This t is no longer a t. It's going to be called an x. So I'm going to say it's 180 times x, or just 180x, is equal to 432. Okay, again, I switched out the t. The time on trip 2 is this time, which is just y. We'll say that this is y. Now I have two different variables, which, as you know, is a problem because I have one equation with two different variables. If you have two unique variables, that means you need two unique equations. So I need another equation. What information have we not used? So I've used the fact that the distance is the same. That's in the fact that distance is equal to distance. I've used speeds. The only thing I haven't used is the fact that one is a 7-hour longer trip. So I need a second equation where instead of talking about distances, I'm going to talk about times, because this is a time. So let's go ahead and say that my second equation is all about time. So there's going to be a relationship between this time and this time. I'm going to somehow have an equation with an x and a y in it. Let's go ahead and set that up. There's going to be some sort of equation, therefore there's an equal to sign. Maybe x and y are on the same side, maybe they're on different sides. It's kind of up to you. So I need to kind of think about the context of the problem a little bit. What does this time mean? Is it a big number? Is it a small number? Well, remember that you don't even have to look at the 7 hours. You can be like, okay, this is a small speed and this is a large speed. Therefore, this trip is going to take a lot longer. This time is going to be bigger. And they're going really, really fast. You're going almost like 3 times as fast down here. So this trip is going to take a lot shorter time. This time is going to be small. So let me make another note here that this is going to be a small number by comparison to this one, which is going to be a big number. So if I do a big number minus a small number, I'm finding the difference. And it did tell us that the difference is 7 hours longer. Longer is kind of a difference word. So I can say a big number minus a small number. I can say an x minus a y. I can say that an x minus a y. And notice I'm using the 2 variables in my equation. The difference there is going to be 7 hours. And it's always kind of good to do a sanity check. Is every single thing that's in your equation the same unit? In this case, everything was a unit of distance because rate times time is a distance. The rate times time is a distance. So everything here was a distance. For these, are all 3 of these time? Just sanity check. X is a time. Y is a time. And 7 is an hour, so it's also a time. Okay, sanity check over. Let's go ahead and see how can I use these 2 unique equations to solve. So whenever you have a system of linear equations like this, you can solve it in one of 3 ways. You can solve it using substitution, or elimination, or graphing. So graphing is a lot of imprecision. I don't like it. It's not precise enough for my means. So I'm going to do either substitution or elimination. Elimination works best when these variables kind of line up. So if I'm going to cheat and drag this one down here, the variables don't really line up really nicely. The x is there, the y's are over there, and there's a number somewhere there. It doesn't really make sense to use elimination here for me. So I'm going to use substitution. So let me grab you and put you over here. The way that substitution works is you want one of these variables by itself. You want it isolated. So I'm going to move this y to the other side to isolate my x. It doesn't matter. I could have isolated the y, but if I did that, that would have meant after I moved the x, I would have had to get rid of this negative for an extra operation, which I don't want to do. So let's just add y to both sides. And when I do that, y's are gone here. And I get a new equation that says y, not y, what's left over is an x. X is equal to 7 plus y. All right, so now I have my variable ready to go for my substitution. Here's how that substitution process works. If x is 7 plus y, then this x is also 7 plus y. So here comes the substitution. I'm going to draw an arrow so that everyone can follow me. This 7 plus y is being substituted in for this x. I'm going to rewrite every 4 of these, I guess 5 of these symbols. And here it goes. I say 180. I want to go back with blue. I like my color coding. 180. There's my x, I'll leave it blank for now, is equal to 432y. I hope that you agree that this is the exact same line as this. And instead of x, I'm going to write 7 plus y. 7 plus y. And notice what I've done. I now have one equation, one equal to sign, right? And I have the same type of variable, just y, which means this is now solvable. Unfortunately, I can look at the bigger picture and say, wasn't I trying to solve for this variable, which was x? Wasn't I trying to find that time x? Why am I solving for y then? Unfortunately, we're solving for the wrong variable, which means we'll have one extra step at the very end of this after we solve for y. But I promise it's not going to be that much of an extra work. How do we solve? I think the best way to approach this is to distribute the 180. Let's go ahead and do that. 180 times 7 is a number. I know that it's going to have a 0 at the very end. And I'm trying to do this in my head. So 7 times 8 is 56. I'm putting 5 fingers up right now so I can remember the 50 that carries over, and then 6 I'm just going to write down. Okay, so I have my 5 fingers, and then I'm going to multiply 7 times 1, which is 7, plus the 5 fingers that I have. 7 plus 5 is 12. So I know this is going to be 12. So 1260. And now I'm going to distribute again. Times the y is going to be 180y. That's going to equal 432y. And I'm noticing that I have variables on the left and on the right, but constants only on the right, or only on the left. I know my sides, that's the left side, yes. So if constants are already on the left, let's move all the variables to the other side, to the right. Let's move the 180y over by I don't know what color I'm going to do here, minus 180y on both sides, minus 180y. And this is the beginning of our class, and just as a review of best methods, notice that when I write like terms, I'm writing them directly underneath each other. The 7 and the y were not like terms, that's why they were not lined up underneath each other. These two are a little bit difficult to subtract, and I don't want to like borrow because it's it's hard. It's too much work. Here's a quicker trick. If you add 20 to 180, it becomes a nice number, and that nice number being 200. Technically, I'm adding 20y, but I'm going to ignore the y for a second. I'm just adding 20. But whatever you do to the bottom, you do the top. So I'm going to also add 20 up here, and still this kind of disgusting number, 452y. But notice that this problem is way, way easier to subtract. I don't know why I didn't choose a different color here. I really wish I would have gone with my lime green. Oh, why did that not change the lime green? Is that the same lime green? I think it is. Okay, so now I can subtract these two, and it's much easier because 2 minus 0 is 2. 5 minus 0 is 5, and 4 minus 2 is 2. It's 252y. Super easy, right? So that means that the left side is 252y, and no, I guess that's the right side. I'm getting my left and rights mixed up. I think it's my Algebra 2 class. They're messing me up. All right, and this is going to be equal to, well, these guys canceled out, right? So I'm just left with 1,260. And from here, what's left to do? Well, that doesn't really line up there, does it? Okay, what's left to do is to just get rid of our 252 by dividing both sides by 252. So divide by 252, divide by 252. Is there a fancy trick to do this? I mean, guess and check is pretty close. I mean, this number is really close to 1,200, and this number is really close to 200-ish. And cross off the 0, cross off the 0. 12 divided by 2 is about 6. So it's probably like 5 or 6. I don't know. You have a calculator. Learn how to use tools appropriately. Isn't that like a life skill? All right, let's use a scientific calculator. I don't know what that is here. Let's clear all. 1260 divided by 252. See, I said either 5 or 6, and I was right. It's 5. Okay, so let's come back over here and say that this number is 5. So 5 is equal to our y. And again, we're not done, unfortunately, because we're not solving for y. We're solving for x. That was the number that we were after. That's this one. So how do we do that? Well, you can plug it into one of your equations. So you technically have 2 equations from up here. You can kind of plug it into whatever one you want, or you can even think about it in terms of the context of the problem, right? We just solved for this one, which is the really fast time, really low amount of time. It was only 5 hours for that trip. So you can come up here and we can fill that in now, or you can say, yeah, that time is 5. And because this time is going to be 7 more hours, I can say 5 plus this 7 up there, and you get 12, which is the right answer. So you can say that x here is equal to the 5 plus, what number is it? 5 plus 7. I was forgetting what I said. 5 plus 7 to get 12 hours for our final answer. But you could have used an equation, right? You could have said, oh, well, my equation up here is x minus y is equal to 7, which technically we made this equation, which is what I basically said. I said to get x, you add 7 and y. You add 7 and this y coordinate, which is 5, and I move that down here. I got 12 hours. Cool. Well, there's our puzzle for the day. I'll see you guys later. Bye.